We're going to move on to Luke Lorrimer, who, moving on to Luke Lorrimer, who's a transportation engineer at MaineDOT. He's an ITS engineer with a master's in mechanitronics. I had to look that up myself, which is interdisciplinary mechanical, electrical control systems, and he's a PE as well, a professional engineer as well, and working for 12 years for MaineDOT, helping to deploy and develop new technologies. Luke?
Well, at least that covered who I am. So I'm going to be talking about half of what we've got on the subject, automated vehicles and connected vehicles. I'm concentrating on the connected side of them. And what we're looking at is what does MaineDOT have out there at the moment and where are we going to be going with it? So connected vehicles, they fall into, well, the connections fall into three types. We've got V2V, which is vehicle to vehicle. This is probably the biggest use for connected vehicles because this is the bit that tells you the car 3 down that you can't see is braking hard and your vehicle needs to apply the brakes. So every connected vehicle puts out what's called a basic safety message, which is its current location, its direction, and its speed. And that's just transmitted constantly. All the vehicles are doing that. So all the vehicles that are connected know where everything else is and can calculate, you know, are we going to hit another vehicle? The second bit is vehicle to infrastructure. So this is your pieces on the side of the road, your signal lights, your pedestrian crossings, your weather stations, your message boards, all of those will be taking in that basic safety message and then, depending on the vehicle's location and direction, sending messages back out to the vehicle. So first, an obvious case is signals. As the vehicle's approaching, the signal's getting that information in, sends out another one saying, by the time you reach the stop bar, this light will be red, this light will be green, this light will be yellow, and the vehicle can, I think I should point out, these vehicles are not necessarily automatic, so for some of them, it will just be putting a display up to the driver saying, this is the information I'm getting in. For others where we've got a level of autonomy, it may be automatically applying the brakes for you, whatever it needs to do. The third section is vehicle to everything. So this is normally a cellular connection to the cloud. And that will be picking up from a central software, whatever information is. So it could be about events 5-10 miles down the road, which a roadside unit is not going to be able to give you information on. It could be upcoming weather conditions. It could be known congestion problems, and that by the time you get to that location, you really should have taken another route. Okay, so how are we involved? At the moment, MaineDOT has 150 signal systems out which have connected vehicle technology on them in the form of roadside units. These are short range units that connect directly to the vehicle. They don't go through a cloud system, it's that direct connection. And they will put out to that vehicle, as I said, it's called SPAT, the signal phase and timing of that signal. So if we tell you what phase your light's coming in on, what color that light is, when it's likely to change. So again, the vehicle can react to that information. These have been done as part of a general upgrade on our signal systems, bringing them up to the latest standards. And as we go forward, we will be increasing that number of signals out there with this technology in. As part of that, obviously, while the signal's putting out the information, it needs to talk to something. So we've also put out, let me check the numbers. I didn't write the number up there. 40, I think it was, onboard units, which are the units which go into your vehicle. These are retrofit units for this particular project, so it's not built into the vehicle, which we're hoping will come later. The majority of these have gone between first responders, transit, our fleet for plow trucks, and a few transit companies for freight. And they serve different purposes, which will come up later on it. But what do we get out of it as well? The DOT gets that data back. So while we're sending information out to the vehicles, we get information back from the vehicles. And we can use that for road planning. So at an intersection, we get the turning movement for an intersection, which is basically telling us how many vehicles have gone through, which leg the intersection they came in, and which leg they left on. And that can be used for road design and planning in the future. If we know a particular signal has got very heavy left turns, maybe we need to add a second left turn lane in to stop back up on that lane affecting other traffic. Or we need to extend the road, or we need to do a bypass because this this signal has reached capacity and we need to find a way to keep the flow of traffic moving. We can also use it if we've got to get some kind of corridor travel time. We know a vehicle started the corridor of lights at this point, ended at this point, we can work out an average speed and see if that is an acceptable travel time, how reliable that travel time is, which actually tends to be more important than getting people to go faster. People like to know when they reach here, they are going to get to the other end in a certain amount of time. And that reliability is a big factor, which does affect all the signal timings down that corridor. Okay, so our current network, we've got 150 signals out there putting out the information. We've got the 40 units out there for vehicles to talk to. Oh, go back that way. So, as I said, we've got the different types of fleet out there: first responders, freight, transit, and our own trucks. So the differences are first responders at signals get something called preemption. If they have their sirens lying, they have their lights on, that signal will stop everything else. It will turn all the legs red. On the approach for the first responder, that will go green. So it clears everything out. They can get through as quickly and as efficiently as possible. The following ones, freight, transit, and plow trucks, obviously, they don't require that level of urgency. So they get what's called priority. And the signal will do its best to make sure that that vehicle isn't stopped by adjusting times. It won't send everything else red. It will go through the phases in the proper order. It will just try and reduce the green times on other legs or extend the green time on that leg to make sure that vehicle can get through. As I say, it's not you're definitely going to get a green, but it tries to stop these vehicles from stopping. Why? Well, transit, obviously people like to get where they're going on time. So getting them through is important. But why freight and plow trucks? Well, freight is actually more a slight environmental concern. Those big trucks stopping and starting takes a lot of fuel, puts out more emissions. Getting them through more efficiently helps everybody. Plus they take time to get up to speed. If you've got a lot of them stopped, all a backup. Our plow trucks, you've all been around Maine. We've got a lot of hilly sections. If an intersection is at the bottom of a hill and our plow truck has a lot of snow on its blade, it may not get going again after a red light. So keeping them moving so that they're constantly pushing the snow out of the way and don't have to try and start up with that extra weight, especially on hills, is a big priority. Also, they tend to keep their main roads clean. People like that a lot, so giving them priority helps keep everybody safe. So future developments, so we want to expand it. At the moment, what we have out there is signal-wise. It's useful for behind the scenes, but to the general public, it doesn't add a lot. They can pull up to a signal, they can see on their little car dash what that signal's going to do, whether it's green, red, yellow. They can also see that by looking out their windshield. It's a fancy gadget, but it doesn't bring them much help. So what could bring them more help? Well, as I mentioned earlier, things like stop traffic up the road ahead. If there's an accident happened, if there's hazardous conditions ahead, so the road's flooded, the road's icy, you're about to drive into heavy fog, you're about to drive into severely heavy rain. Having that information, you as a driver can make a decision. Do I want to drive into that? Should I just drive slower? Am I already, as it's pointed out, if I'm already tired, maybe it's best I stop and rest until these conditions pass. Also, for our own crews, work zone warnings. If you know there's a work zone coming up, you can start preparing for it rather than coming over a hill and into a flagger who wasn't expecting you. I mean, the signs are there, but we don't always pay full attention when we're driving. So that helps the people with the unit in their car, but as Steve Landry, who's not here, often likes to say, The average age of a car in Maine is 12 years old. We're a long way from having this technology being universal in the vehicles. I mean, not every vehicle in the market now has it built in. We're still away from that automatic inclusion of it. So we're working with our partners at, let me make sure I get the right people. It's called AI. Sorry, Brooke, what's the acronym? Applied Information. Putting together an app which will go on the smartphone. And that will provide you from your smartphones these warnings as a spoken audible warning. So you don't have to be staring at the phone. So when you approach the signal lights, it will tell you, warning, lights red, you're approaching too fast, so that you can apply the brakes and stop and not run that red light, or let you know that the green is going to be up in a couple of seconds. As we say, we're testing that. There are some difficulties that weren't expected when we came in, but once it's in place, we will then expand it into these other alerts. So you will get the stop traffic, the weather result, weather alerts, congestion. And that is me done.